Hello and welcome back. I hope you enjoyed that short break. I opened the IDE. I also created a folder called PWM in the desktop, and I created another folder called target. So now let's go in and learn the programming. So before that, you have to um, select the path, change to the other workspace. So make sure you are on the correct path. So it's PWM target, so that's okay. It's on the correct path. So you got to go file, new STM32 project. It's still loading on the background. Still loading. I'll close the information center. We don't need it for now. So on the background, it's loading the files. So just few seconds. Because we changed the workspace, so it has to do all of these checks before it lets us to choose the target board. File, new. Let's try again. STM. Yeah, now it will ask us to choose the target selector board, which is good. We can choose it. Still it's thinking on the background. Just give me a minute. Okay, there it is. So it started now, so let's start. Okay, you know where to go. So board selector, and then type in nucleo board, nucleo F411RE, and then select this board, click next, and give a project name. We are on Day22, so I'll represent that. Day22 PWM, and we're going to start from scratch. So select the target project type as empty and then finish. This will create the project tree. As you can see, the folder already created. So now we're going to use the internal header files today, like we did at LCD. So you need 3 files to be copied across. I'll show you. You need to go to source, open main.c, and remove all the internal default coding lines. Still loading. I'll remove myself from the screen so you can see the screen. Yeah, it's loaded. So I'm deleting all the internal files that we don't need. I will zoom in a bit so you can see a bit better. Window editor, zoom in. Yeah, I think you can see that better. So now you're going to include 3 files. To do that, you need to go to that extracted files. That's in the folder. So go to here, and the first one is, you need to go to drivers, CMSys. You got to go to include, and not include, device. stm32 then this include. So make sure that file f11 411 is here. Yeah, okay. So copy this link, copy, come here to the project, file, okay, sorry, not the file, come to the project, right click on the project, go to properties, then go to C++ build. In this, go to settings. In the settings, you need to come to MCU GCC compiler, and then you need to click on include paths, and you need to include this path first. So control paste. Okay, so one path is included. Likewise, you need to copy two more paths. So this time, go back to the main folder, include. You need this pulse width modulation, go here, then go drivers, CMSys. Instead of going device, now you need to go to include, then copy this path, come here, include paths, add, and paste it here, and then click another path. Now you're going to include the core M file. To do that, again you have to go back to the file that you extracted from. Go back to one, and then go to device, go to ST, and make sure, not this one, sorry, it will be in core device, core, include core M4H. Okay, so include, copy this, come here, add the path, core M4. Yeah, okay, so that's created. So now you need to go and copy the preprocessor file. So here you need to include the Nucleo file. So I'll click apply, okay, and apply and close. Okay, as you know, you have to reload that into quotes when you use the internal header files. So you have to include those files in double quotes, include space stm32 f4xx.h. Okay, so once you've done that, so right click on this, open declaration. Now you need to declare the symbol, and scroll all the way down to copy the STM34, the symbol 411. Yeah, copy this XC, and then this is the one you got to add in the preprocessor. So right click, properties, C++ build, go to settings, go to MCU GCC compiler, go to preprocessor, and then click on add and paste the symbol here. As you can see, it will be pasted here. See, it's pasted. So now you did all the required file copy over progress. So when you compile, you won't get any errors. So the internal file's been linked and it's ready to use. So I'll say apply and close. We don't need this file. So I'll save this and I will run this program to see for any errors. Build project. So this is going through and it should be okay because we did all the internal file additions to the paths in the preprocess, so it's all set now, so we should be able to use this. In the meantime, have your logic analyzer connected to the board. This is my logic analyzer. I'll show you the short video. My board is connected and this is the logic analyzer. So that's connected. We're going to connect it to port A5, PA5. So I'll take my video off so you won't get distracted. Okay. So now we got 0 errors, 0 warnings. That means all the header files are linked and copied across. Now we are good to go to write the program. Okay. So before going that, we need to check on the data sheet. So I'll open the data sheet in here. As you know, we're going to use timer 2, and timer 2, it's in a functional block diagram on data sheet. We go to data sheet and page 15. This is the functional block diagram. Go to timer 2. So we're going to use timer 2, and that's connected to APB1. So you need to enable this clock APB1, and you're going to connect to the GPIO port A. That's where the LED is connected, PA5. So you need to enable this clock, and that's connected to the AHB1. So you need to enable this clock as well, and connected to the bus matrix, and that's connected to the microcontroller. So we need to enable all of that. Okay, so the first step is that, and then you need to find out where the timer 2 channel is connected to the GPIO. So again, you have to go to the reference manual this time and look for alternate functions. Once it loads, then I'll show you the alternate function. You need to find out which channel this is used. We're going to use port F5. So GPIO, first I'll show you the GPIO registers. GPIO port mode. So we're going to connect to the modder 5, meaning PA5. So I'll refresh it one sec. Okay, we're going to connect it to PA5. So that's port pin 1, PA0, PA1, PA2, PA3, PA4, PA5. You need to set this as alternate function mode, so 1 0. So you got to write bit 11 as 1 and bit 10 as 0. So that's the output modder type. And then you have to look for the alternate function, which will be not here on the data sheet. Click on the contents. It will be on the memory mapping description. Okay, data sheet. I'll look for the data sheet. Do a search, alt function. Or I should write alternate function directly. Alternate function. Okay, so we're going to connect port A modder 5, which will be AF1, PA0, 1, 2, 3. It will be connected to the PA5, that's the 20th pin as 1. So this pin should be written as 1 because that's the port modder. So if you connect that, then it is connected to AF0. So that's AF0. So you have to reset all the pins to AF0. You can also check that by going to the alternate function table. I'll show you. That's a timer in the chart. Alternate function. I think it's on page 237, 230, 147. General purpose, alternate function used. Okay, that's a general purpose alternate function. System alternate function event out, alternate function STM32, output configuration. So it should be nearly here in this page 150, right? It's 240 and 198. That's the vector table. 199. Okay, it's in the data sheet alternate function on page 38. So this is the one we are looking for, and we're going to use timer 2 today. So the timer 2, if we scroll down, alternate functions, that's timer 1, we want timer 2. Okay, the table is here. So we're going to use timer 2 channel 1, so that's connected to PA5. So that alternate function mapping is AF01. It's on page 47 on the data sheet. Page 47 on data sheet, if you go to alternate function mapping, we're going to use timer 2 channel 1, that's connected to port A5. That's where the LED is connected to. So that alternate function is AF01. So if you come here, alternate function of the GPIO, alternate function low, sorry, it's a bit slow. Alternate function, come on. Oh yeah, okay. If you come up, let's see, capture mode, alternate function. We need the GPIO registers. GPIO registers. Yeah. We're going to use port modder 5, bit 11 and 10. So that's good. Output type register we're going to use. We're going to use data register, output data register bit set. Okay, here it is. It's on page 159, alternate function low register. We're going to use AF1. So you need to set 0001 on the port 5 modder. So bit 20 you got to set as 1. So port 0, 1, 2, 3, 4, PF5 is here. So these 4 bits you got to write 0 0 0 1, bit 20 as 1. You'll see that in the program. I just wanted to show you in the data sheet. Okay, so first step, we need to enable the clock access for both the GPIO port and also for the peripheral. So let's do that. First, we're going to enable the clock access for GPIO A, because we're going to use port 5, PA5. So by register going here by the previous sessions, you need to enable this HP1ENR, because we're going to use port GPIO port A, so you can write it like that. So this is enable. Okay, next one, you need to enable so I'll copy this. You need to enable the peripheral clock now. Control C. Enable the peripheral clock, that's APB1 ENR. So again, RCC, you go to APB1 ENR, you have to set that to 1 as well. Now you need to set the alternate function mode register, the output register. Set the mode register for alternate function. So you name it GPIO A and moder register MODER, and you got to set the output type, which is 0 cross 1 2 3 4 5 8 0 0. This is 32-bit, so we are setting bit 11 as 1 and bit 10 as 0. So if you calculate that, you'll get the 8, so that's why I put the 8 in there. Okay, so the next step is to configure the AFR, alternate function register. Configure AFR registers. We need to include AFR 01, so the 20th bit has to go 1, 20th pin. So to do that, GPIO A, we know it's AFR 0 lower, and just simply add that with this value 0 cross 0 0 1 0 1 2 3 4. This being, if you want to check, I'll put a comment so you can go and check AF 0 1, which is, you need to set this value 0 0 1, so that is 20th pin, 20th bit has to be 1, set as 1. Okay, let's check so far. Save this to see if we have any error. Save, right click, build the project. Okay, that's a good sign, 0 errors. So now let's go for the timer registers. I will start with timer registers. Okay, the first one is timer 2. We need to set the prescale value. As from the slides, if you remember, you got to write it like this. So we're going to divide the timer clock by 10. So divide the timer clock by 10. In the next step, you need to load the auto reload register. So timer 2 auto reload register value. And this is the value for 30% duty cycle. So you can vary it by, I'll show you. So this is 30% duty cycle value. If you calculate that, you'll get this value. Duty cycle. Okay, then you're going to set that to the counter to give the current value of the counter, starting with 0. So you need to say that. Then timer 2 register the capture compare mode register, CCMR1. MR1, you got to set this as 0x0060, meaning enable the pulse width mode, which is nothing but CCMR1, that is bits 6 to 4 should be written as 110. So the binary value will be 6. If you write 0110 is 6. So this is the pulse width mode. Okay, so the next one is you need to set that into the timer control register, and then you need to enable the pulse width modulation with this register, CCER enable register. You have to set that to 1. So we are enabling pulse width modulation channel 1. And then the next register is timer 2. You need to set that to this control register or CCR register. The value is, if you calculate the formula, you will get this value. Then start the timer by this register, CR1 equals 1. So we are enabling the timer, enable the timer, and put a simple while loop, while of 1. Okay, so now save this program and do a build to see if we have any errors. Right click, build project. In the meantime, I will also open Logic Analyzer software and keep that handy so we can see the output using the Logic Analyzer. Logic Analyzer. Pulse view. I'm opening the pulse view logic. Okay, that's good. 0 errors, 0 warnings. So now you need to set the debug operation. So right click, debug as select the debug configuration, and choose STM32 C++, double click and make sure it connects to the pwm.elf. Go to the debugger, you need to enable ST-Link and also enable the serial wire viewer, apply and click on debug. This will move to the debug perspective mode. So look on the right click and debug STM32 application. So it's trying to connect, as you can see, trying to look for the targeted board. It's not going to connect. Okay, I need to, okay, found the board, sorry. It took a long time, so now it's 4%. Because it has to download the program and put it in the microcontroller memory, so that's why sometimes it takes longer than the usual. So 51%, that's good. %, so just be patient, it will be ready shortly. 90%, yes, switch. Okay, I can see the LED flash. LEDs flash, so 93%. We have to wait until it hits to the 100%, and then we can check the output. So download verified successfully, that's good. 97%, it's verified successfully, good. So we are inside now in the debug mode. So I opened the pulse width modulation already, so I'm going to go here and already connected to the device. So I did a search and scan for the device. Okay, that's the one. So connect. So it's connected to this device. So I'll go here and run the program. And come here. Run. So now, as you can see, you can the cell logic, because it's connected to D0, so you can see the D0 is high and D1 is low. Yeah, D1. I will stop. Okay, so I'll go zoom in. Zoom. So these are all the points that it changes the point like that. Yeah. So frequency. I'll change the frequency to 16 megahertz and then hit run again. terminate and relaunch, and I'll rerun again. Just trying to show you a different value here. Turn it off, turn on. Scan for the device to the port. Scan. It's connected now, so switch. Logic Pro, no, it should come as FX2 like it did last time, FX2. Okay, so I'm going to run no, suspend. I'm going to change the value here to 1667 just to change the value with a different duty cycle. I'm going to run this program now with a different duty cycle. So terminate and relaunch. Project Explorer, right click, debug, STM32 application, this, okay, should connect now. I can see the LED light on with the intensity. I'll show you the intensity of now. So it is off now, LED. Okay, I will go and run this program, run. As soon as I run, look at the LED, so that's the intensity. This LED here, this one. So you can practice this yourself. Now I can see a difference in the intensity, the accuracy of the brightness, it has reduced a lot. And also you can also come here and do a run, pulse view run. Okay, it's not responding, sorry. But it is working. So if you go and write your program and then close the program. I'll open again and do a run to see. Pulse view app, open. Still waiting for the pulse view to open. Just one sec. Pulse view app, open. Okay, it's scanning for the devices. Just one moment. Okay, so connect to a device. It seems my logic analyzer has intermittent problem. You saw here, right, 8 channels, so now it's not connecting. I don't know why that is happening. Well, reconnect again. Scan for, yeah, it's connected. So, okay. Okay, so now, close that. I'll run here again. Go to my pulse view and then do a run. And as soon as you run, you can see this variation. So I will stop now and zoom into capture. So it is working. I can see the intensity of the light brightness, but I want to show you here in the form of the output. I couldn't vary the trace to show you, so okay, with this I conclude. You try in your end, and I'm sure you'll get the output. So let's go back to the presentation where we left. I'll take my video Y. So this is where we stopped, and so what we learned what is PWM, and we learned how it is used, and we generated with 30% duty cycle, and we modified that to show the intensity of the light change, the LED. So as I said earlier, you got to also develop your mindset as well as your skill set as well. So these are all the points I would like to let you into consideration. Pay the price for the person you want to become. So if you want to get a higher payout in anything, you need to be like that person. So first always give out and then expect. So that's my second point. Don't expect money before you provide any sort of service. So always provide your service first, then accept money. And that also includes in your work situation as well. Show your potentials, show your skills, so that will fetch you to get more money. And also the third point, give what you want. You should be prepared to give what you seek. So that's what it is, give what you want, and do plenty of charity. The more charity you do in terms of money or work, the better good things happen to you. So these things I would like to take to your consideration. Also, don't forget the mindset involvement. Write down your top 10 goals, write down your top 10 ideas to achieve those goals, and spend at least 30 minutes for your exercise and workout, and spend at least 15 minutes to meditate or pray, and 10 minutes to visualize of achieving your goals, and 10 minutes to focus on your day plan activities, and 2 hours of learning and taking down notes will get these points. So please do post all your achievements in this Facebook group so everyone will learn from each other and motivate from each other. And there is combo internship coming your way. I don't want to include everything in one course, so I divide it into 3 different courses. We are on advanced, so please purchase the whole 3 courses to get the full benefit of Cortex M4 series. And also, please stay tuned with us, and these are all the programs in progress, and you will be the first person to know. Once it's available, then you would be able to get all of this and update your skills. And I sincerely take this time to thank you at this time. So thank you so much for your patience to learn today, and go and enjoy that lovely break from the screen. This is Arul Anbukarasu. I'm signing off on behalf of A2DG. I'll see you in the next session. Until then, take care and have a lovely time. Huru for now. I'll catch you in the next session. Take care.